Welcome back. This time we're going to talk about evaluation metrics. But before we begin, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. So, evaluation metrics for classification and regression. Model evaluation extends far beyond accuracy. Understanding precision, recall, F1 score, AUC, ROC curves, PR curves, and RMSE is essential for selecting metrics that align with specific business needs, whether detecting fraud, screening for diseases, or powering search engines. So, how do you understand the metrics? Let's go through these. Uh-oh. So, I'm going to go a little bit out of order, but see these on the page. Recall, also called sensitivity, true positive rate, or completeness. This measures how many actual positives your model correctly identifies. Use recall when false negatives are costly, missing fraud cases, or disease diagnoses. If you have 5 true positives but miss 10 cases, your recall is only 30%, 5 out of 15, right? Precision. This is the positive predictive value or relevancy. This measures what proportion of positive predictions were actually correct. Prioritize precision when false positives are costly, like medical tests or spam filters. If you have 5 true positives but 20 false alarms, your precision is just 20%. F1 score. This balances precision and recall through harmonic means. When you use F1, do this when you need balance on imbalanced data sets. The harmonic mean punishes extreme values. A model with high precision but low recall, or vice versa, will have a low F1 score. Specificity. This is the true negative rate. This measures how well your model detects actual negatives. This matters when correctly recognizing non-events is crucial, like reducing false alarms in security systems. RMSE, root mean square error. This applies to regression models. The formula represents the standard deviation of prediction errors. It's sensitive to large outliers. A few bad predictions significantly increases RMSE. ROC curve. So this is the receiver operating characteristic. This plots true positive rate or recall on the y-axis against false positive rate on the x-axis across various classification thresholds. A curve bent toward the top left corner indicates strong classification performance. ROC curve becomes less effective on highly imbalanced data sets. AUC, area under the ROC curve. This quantifies ROC performance. The values can range from 0.5, which would be a random chance, to 1.0, which would be a perfect classifier. AUC represents the probability that your model ranks a positive sample higher than a negative sample. Use it to compare classifiers. Higher AUC means better performance. PR curve. Precision recall curve plots precision on the y-axis against recall on the x-axis. Use PR curves for highly imbalanced data sets where negatives vastly outnumber positives, like document retrieval or rare disease detection. Higher area under the PR curve indicates better performance. PR curves are preferred over ROC when you have many more negatives than positives. So, choosing the right metric. Your business context determines the appropriate metric. Fraud detection prioritizes recall. You can't afford to miss fraudulent transactions. Medical testing might prioritize decisions and precision within them to reduce false positive diagnoses that cause unnecessary treatment. Search engines balance precision and recall through F1 score. Regression models for pricing or forecasting use RMSE to quantify prediction error magnitude. So, how does this integrate with AWS? All right, so SageMaker has algorithms built in to automatically calculate many metrics during training. Linear Learner and XGBoost report precision, recall, F1 for classification problems. Regression algorithms report RMSE. SageMaker experiments and debugger capture these metrics for comparison. Studio notebooks provide full flexibility to calculate and visualize any metric using standard Python libraries. Costs. So SageMaker training jobs bill by instance hour. An ML.M instance would cost approximately 25 cents to $1 in an hour, right? Studio notebooks charge for compute kernel time plus storage. Debugger, experiments, and profiler add logging, storage, and slight compute overhead. You have to calculate the evaluation metrics locally or in lightweight notebooks to minimize costs. You don't need expensive GPU instances to compute metrics, only to train models. So while you're doing this, use the free tier or minimal instances for metric calculation and visualization. So for the exam, when questions ask about choosing metrics for imbalanced data, fraud detection, medical diagnoses, or comparing model performance, understanding which metric aligns with the business costs of different error types will guide you to the correct answer. Anyways, thank you for joining. Before you go, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. Thank you, and have a good day.